ahead.
Hey everyone again. I will try to be rather short so that we're making it on time. But let me start with a complete off topic. So eye is one of the most powerful senses that has ever been created. Well, it sounds very obvious, but let's really think of that. You're watching the webinar right now with your eyes, which is great, but life is much larger. You're just one of the species on Earth. Earth contains a lot of different animals, and all of them are really, really different in terms of what they want to achieve. For example, a lion is just interested in hunting their prey, but maybe there is like more peaceful animal which is just looking for a safe part of land where this animal can eat grass. There's also a bird which will maybe be hunting, maybe be eating grass, but would also be flying up and down because it lives in actually a three-dimensional space. Well, the point is all the animals have very different needs they need to fulfill in order to survive. However, we have seen that the majority of them have been relying on not on computer vision, but on their own vision, so essentially on their eyes, to make the goal achievable. Well, this is actually remarkable because it makes vision a very, very versatile tool. Well, it goes without saying that vision without the brain is kind of useless. For example, here you see some big cats hunting some buffaloes. I think it's buffaloes. I'm not very sure about that. So it's actually a very difficult analytical task. You don't only need to see the buffaloes, but you also want to understand which buffalo is the slowest, which one is the weakest, which one has the most fat, and so on and so forth, so that you actually do the proper optimal hunting strategy. Well, the cool thing, they rely on vision. And the cooler thing, we know this works because otherwise these animals will not be with us today. So all the animals who rely on vision are actually still alive. So no, it's a very good strategy. And it's also very obvious because our world has light that is just reflecting from different surfaces. So it's a very, very natural, very, very versatile sensor. Okay, I think I'm done with philosophy. Let's try to understand whether it's actually can be applicable to some actual proper case. Well, for example, to a busy airport. The statement is yes, it can be applied very, very well. And the same thing which happens in nature and is called vision and eyes and brain is translated into camera and computer vision. So let me show you a couple of examples to enlighten you on how many different things can be done if you just install a single camera on your ramp. So let's start with safety. Well, what you see in this, not yet, now, yeah, what you see now in this simulation is a plane arriving at the stand. What you maybe don't notice is that it's doing it incorrectly. So although the nose of the plane is already at the stand, you see that the plane is actually not very properly aligned with the stand. It still has some angle to the stand, which leads the left wing of the plane to go actually outside of the stand border. Well, this is very dangerous. And accidents of this kind, when a wing of the plane hits something, already costs billions of dollars a year for the industry. What is even more remarkable, if you see this bubble to the right, it happens in almost all the cases. We have done our own study and we have seen that more than 80% of planes are actually understeering. Well, this is a huge issue because if you want to make the stands more dense, which is very important because the land of the airport is very expensive, you have to do something with that. So let's suppose you want to monitor your pilots and want to monitor who is doing the proper oversteering and which pilot actually, so you just want to understand which pilots are doing oversteering. So you can equip your plane with sensors. You need a couple of GPS sensors to get the location and the rotation of the plane, but it sounds pretty painful to equip all the planes with such sensors and also get the data from that. But what is very cool is that if you have a single camera at your apron, you can solve the same problem using this camera. So modern computer vision solutions allows the camera to understand the 3D world around it, which essentially means that the camera will know how the stand is structured. And then the problem becomes very, very trivial. If you see the image on the right, once you know how the stand is configured, you can just know what traces do the wheels have to follow to actually bring the plane to the parking position correctly. And once you know these traces, it's very easy. You just trace the wheels of the plane, and if they don't follow the traces, well, then the oversteering didn't happen, and the plane has parked incorrectly. So this is a very, very easy way of monitoring the very complex event. And essentially, the only thing you need is to install one camera at the stand and you can get unlimited data, which works for every single turnaround, be it day, be it night, be it a long one, be it a short one, unconditionally of the plane type, and completely automatically. Well, another case which is similar and different at the same time is this speed tracking. A safety issue which we observe with multiple customers is that they want to understand the speed of the pushback action. So this is needed because usually objects on the stand are not supposed to move faster than a human speed, which is usually defined as 4 miles per hour. I know it's a bit deceiving in this video because it has the European metric system, but it doesn't matter. You just need to measure the speed. Well, again, you can just do it with a single camera located at the apron. And if you use computer vision in the end, after the turnaround has been, after the pushback of the turnaround has been commenced, you can get analysis like that. What is very interesting and remarkable is that it's actually a very valid problem. We have observed that almost 20% of towing actions are happening above the speed limit. So people are actually speeding quite a lot. What is also very interesting is that this case is extendable to a much larger case, because usually when you as an airport or as an airline want to monitor the safety, you don't really care about the speedback of a pushback action, but you also care about every object which can be speeding, every little truck, every little car, every little dolly. So the great thing is that if you have a camera installed at the stand, you can essentially measure whatever you want. You can measure anything which moves, you just have to program it, and then you get a full safety monitoring system which monitors everything you want 24/7 with just one camera. Feels pretty exciting to me. Well, that was the insight into safety. There is also one thing which is relevant to some of the people involved in the airline industry, is actually on-time performance, because that's essentially a primary goal of good ground handling. You want to have planes leave on time. So for that, you want to have as much information about turnaround as possible. And the great news is that computer vision is a perfect tool for that. By having 1 or 2 cameras at the stand, you can actually get all the relevant information you need about the stand, about what's happening to the stand, to the aircraft in the system. You see here an example of a Assaia system running in real time at one of the airports. And what you see is that it's constantly delivering timestamps, which are of very high quality, which are, what is important, free of any bias, because we know that human timestamps can have some bias, and which are delivered continuously. Well, the great thing is that having this information, you can on one side predict when the plane will leave, which is essentially important for many tasks, for example, stand allocation. What you can also do is to control the turnaround. And if you see that something goes wrong, you can still maybe fix it and save the turnaround from being late. The information that Assaia is providing is essentially free to be integrated with any other source of information. For example, we integrate with Springshot. But what is very interesting about this information, and that's what I wanted to show on this slide, is that we really collect information from different agents of the process. So what do I mean? Here you see an example of catering and fueling activities. What usually happens on the ramp is that although you have some turnaround, some ground handling provider, fueling and catering is happening with different suppliers. So monitoring their performance is very difficult, both politically and engineering-wise, because you need to collect the data, you need to get it real time, and it's just a huge mess. However, you just care about turnaround as a holistic process. So what happens is if you have a camera which observes what's happening to your aircraft, you can essentially monitor whatever you want. And in this case, you also see, for example, catering and fueling directly integrated to your system, so you get all your relevant data absolutely magically just with 1 or 2 cameras installed. Well, I think this more or less concludes this short demo of computer vision I wanted to make. I wanted to highlight that although we're talking about the ramp of the future and the technology still looks pretty futuristic to me, although I'm essentially a computer vision guy, this is not the future, this is the reality. Computer vision is already available today. Assaia is an excellent example of that. So very excited, very excited about that. Thank you very much. I think Jan